All right, let's dive right into this explainer and absolutely shatter the idea that knitting is just some simple, cozy hobby. Today, we're pulling back the curtain to reveal the intense, highly sophisticated mathematics hiding in plain sight within every sweater, scarf, and pair of socks. We are going to look at how a simple strand of yarn transforms into incredibly complex geometry. So ask yourself this. When you picture knitting, do you just see someone sitting there counting stitches? Because we're about to take a journey from a single loop of yarn all the way up to the cutting edge of modern material science. The crazy thing is, the scientific community is really just now catching up to what knitters have known for centuries, that knitting is literally a masterclass in structural engineering. It's been said perfectly. Knitters already do mathematics, not memorizing formulas, but craft mathematics. If you've ever picked up a pair of needles, you are already an intuitive mathematician. You're constantly manipulating structures, predicting shapes, and translating these really abstract instructions into physical realities with your own two hands. You don't even need a chalkboard. Your laboratory is right there in your lap. Section 1. Beyond just counting. It is so much more than arithmetic. Now, most people hear knit math and immediately think of counting stitches. But just look at this translation table. Your everyday knitting experiences map perfectly onto 5 distinct branches of advanced mathematics. Calculating gauge? Sure, that's arithmetic. But when you shape a flat circle or a sleeve, you are diving straight into geometry. When you cross a cable or, heaven forbid, experience the sheer panic of a dropped stitch, that's topology. Knitting ribbing is a study in symmetry, and dealing with stretch and drape, well, that is pure mechanics. It's a deeply multi-layered mathematical discipline. To put this into perspective, compare a standard piece of paper to knitted fabric. Paper has flat, incredibly stable dimensions, right? But knitted fabric, it's a live structure. It biases, it stretches, it curls up on the edges. And this is exactly why swatching isn't just some annoying chore keeping you from starting your sweater. It's a vital laboratory experiment. You are literally testing how a live, flexible structure behaves under tension with specific materials. Section 2. The geometry of shape. Let's explore curving fabric. Geometry in knitting pops up whenever you want something that isn't just a basic rectangle. A flat dishcloth represents zero curvature. But the second you decrease stitches to close a hat into a dome, you are literally manipulating positive curvature. Conversely, if you add stitches to make a ruffle flare out, giving the edge way more length than the fabric can smoothly absorb, you are creating negative curvature. You are sculpting three-dimensional shapes out of a one-dimensional line of yarn. How cool is that? So think about a technique like a short row, where you knit part of a row and then turn back early. That isn't just a clever knitting trick, it is a deliberate, calculated act of local geometry. You're adding material to one side of the fabric but not the other, which forces the textile to curve, fold, or cup in 3D space. That's exactly how a sock heel is formed. It is localized geometric manipulation at its finest. Section 3. The topology of loops. Zooming in, we see why connections matter. Okay, before we go any further, we need to define topology. Often called rubber sheet geometry, topology and knitting is all about preserving the continuous structure of the loop dependencies. Basically, it asks, what remains true if you stretch or squish this piece of fabric, as long as you don't cut the yarn or pass the strands through one another? Think about the fundamental difference here. When you block a lace shawl by pinning it out and stretching it, you're changing the geometry, its physical shape, but the loop connections remain completely identical. The topology hasn't changed at all. But if you drop a stitch and it runs all the way down the fabric, the topology itself changes because those continuous loop dependencies are completely undone and destroyed. And this topology translates beautifully into wearable art. Take the knitted Mobius, for instance, a loop strip with a half twist that literally only has one side and one edge. Legendary knitters like Elizabeth Zimmerman and Kat Bordy proved that a Mobius band isn't just some mystical mathematical novelty studied by professors on chalkboards, it's a wearable structure you can physically cast onto your needles. In a Mobius cowl, sidedness becomes the fundamental structure of the garment itself. Section 4. Fabric as a metamaterial. It's all about engineered architecture. Here is an absolutely crucial realization. Knitting creates stretch from structure, not just the yarn itself. Think about pulling a length of plain wool yarn. It barely stretches, right? But if you knit that exact same yarn into a ribbed cuff, it expands dramatically. The massive elasticity of the cuff comes entirely from its engineered architecture. Because its large-scale behavior comes from its internal loop structure, knitted fabric is actually a highly sophisticated metamaterial.
Now, this metamaterial behaves totally differently depending on how you pull it. Because loops connect differently side to side, which we call the course direction, than they do up and down, the whale direction, knitted fabrics possess what physicists call anisotropy. That just means they stretch and behave entirely differently depending on the direction of the force you apply. So ribbing stretches way out across, but not nearly as much up and down.
And this mechanical reality actually explains everyday knitting frustrations. Stockinette fabric curls constantly. Why? Because the knit face and the purl face are mechanically unequal at the surface. Each side inherently wants to curve in a different direction. So when a knitter adds a garter stitch border to stop a scarf from curling, that isn't just a pretty decorative choice. You are actively deploying a mechanical intervention to balance opposing physical forces.
Section 5. Programming the future. We are literally coding with yarn. You see, knitting is quite literally a form of coding. A standard knitting pattern is essentially a flawless computer algorithm. When you knit, you are executing variables like gauge and size. You run loops when the pattern says repeat from start to end. You follow conditionals, like if working size medium only. And you execute subroutines when you pause the main body to turn a heel or work chart A. You are a human computer compiling a three-dimensional object. Today, the frontiers of knit tech are just exploding, precisely because of this code-like structure. Researchers are building graph-based models and computational synthesis tools, like KnitGest. They're formally translating a knitter's tacit, hands-on knowledge into predictive engineering. This research is paving the way for incredible futuristic tech. We're talking soft robotics, wearable sensors, and highly advanced medical textiles. They're using stitch topology to program mechanical properties stitch by stitch.
The ultimate dream of this frontier is something called inverse design. Usually a knitter asks, what shape will this pattern make? Well, inverse design asks the exact opposite. What pattern will automatically generate this specific 3D shape? Just imagine a world where we could ask a computer for a seamless, breathable medical knee brace with precise local compression, and the computer instantly calculates the exact topological stitch plan to weave it into existence.
Ultimately, knitting is arithmetic you can wear. It is geometry you can block. It's topology you can drop. And it is mechanics you can feel. This brilliant framework shows us that craft knowledge has always been a deeply sophisticated form of material mathematics, and it is finally, rightfully, being recognized by the broader scientific and engineering community. I want to leave you with this final thought. Take a second and look at the knitted clothes you are wearing right now. What complex algorithms, what topological loops, and what advanced physics are hiding right there in your stitches? It completely changes how you look at your everyday wardrobe, doesn't it? Because now you know that you aren't just wearing a sweater. You are walking around in a highly engineered metamaterial. Thanks so much for joining me on this explainer, and keep questioning the science of the everyday.